guys, welcome back with another interesting tutorial of MATLAB, and today we are going to see how you can animate the plots. In past we were looking at the static plots where when you plot a function or when you plot a line, you can see the final shape of that function or final shape of that line. However, that line is created by the dots connected together progressively, so you can't see that increasingly points added to that plot which make up the line. So in this video we are going to see how you can see that the dots are being connected and the line is being plotted. So you can do it in MATLAB, and there are two functions that are going to work together to create that line. So the first one is h is equal to animated line. Animated line is the function that creates an animated line but that has no data and adds it to the current axis. So the plot is created and this animated line function is added to those axes. And now if you want to create animation by adding the points, you can add points by using the add point function. So first we are going to create this animated line function in the figure, and then we are going to add points to that so that we can see that animated line. So let's get started with this. H is equal to animated line. You can see this plot here, which by default starts from 0 to 1 for x-axis and 0 to 1 for y-axis. We can dock it first. Now axis, you can specify the range of the axis. For example, the x-axis you want to see it from 0 to 4 pi, and y-axis you want to see it from -1 to 1. So when I run it, you will see there is a change in axis. As I said, the y-axis is from -1 to 1 now, and the x-axis is from 0 to 4 pi, and 4 pi is around little bit more than 12. So that is what you can see. The graph has x-axis little bit more than 12. Now you want to create a x function. By the way, the reason I used it from -1 to 1 and from 0 to 12 is because the x and y values that I'm going to use in this example are within this range. So we want to see all that figure in this plot. So we have x is equal to line space 0 and 4 pi, and it has 1000 points. So this specifies 1000. So from 0 to 4 pi, there are 1000 points along the x-axis. So you can see this vector x has a length of 1000, and the y is a function of x, and we are creating that as well. So you can see y also has 1000 points. So these two are consistent. And now there is another command that is tick and talk. So you can, when it says tick, that means the timer or the clock starts, and when it says talk, that means the clock ends. So between tick and talk, you will see an output that how much time it took to plot this thing. This is important because you want to see how much time it is taking to plot these 1000 points on this MATLAB plot, and maybe you want to increase or decrease that rate. So we will do that, but first let's have a check on it, that how much time it takes by default to plot it. Now within the loop, the length is again length of k, and length of x, and x is 1000, so that means 1000 points, and add points. So within add points function, you have to specify the plot animated figure that you want to call. So this is the figure h, and then x of k, that means the x element corresponding to this kth loop, and similarly the y element corresponding to the kth loop of this y vector. So these two x and y points are being added, and then draw now is again capturing the frames. So when I run this one, you will see the plots being added, the points. Now you can see here this line is being drawn, and you can see how progressively it is being drawn. This is very interesting. Now if you want to save these data points, you can use get points function of this plot h. So let's say if you don't have the points created already and you have some function, you want to get the corresponding points, you can say x data and y data. So x data and y data is going to save the x and y values of this plot in the form of these two variables. So currently you can see here in workspace there is no x data and y data vectors. But when I run it, you will see this x data and y data, which are exactly equal to x and y, because this is the reverse of the input. So that is how you can get your data points. And clear h is basically if you want to clear this plot, so that means it will remove the plots, remove the data points plotted. Okay, and draw now basically removing all these two commands together. Now you can specify the animated line properties. It is exactly similar to what we were doing in the static plots. So here you are creating h is equal to animated line, right? Within that you can specify your properties. For example, you can specify color is equal to red, you can specify length with line width of 0.2, marker type of square, marker size of 6. So all that you can do. If you haven't seen my previous video about specifying the line properties in static plots, I have dropped the link in the description. Please pause this video and check that out so that you can understand about these commands more in detail, and then come back to this video again. So yeah, we are going to create use these properties to assign to this plot h, and then next is again the similar command that we did here in the previous section. So everything is same, just only that we are changing this property. So let's run this. Now you can see here these are squares and this is red, and the thickness is also specified. Marker size is thick, so that's why you can see the thickness is more. The line is line thickness, line width is small, so that's why if you zoom it, you can see the line width here. See, the line width is small and you can see these squares. Okay, so that is how you can create with choosing different properties. Now the next thing is that set the maximum number of points. So currently you are seeing this whole line. If you want to see only a specified number of points, let's say you want to see only 100 points, you can do that by specifying those number of points, and only those points would be shown here. So that can be done within this line where you are specifying the line properties. You can specify maximum number of points, and I have specified 100 here. So let's see how it looks. Yeah, now you can see these 100 points are moving and the previous points are being removed. So that is how you can specify the number of points. It looks like a snake game that you play in the old days. Okay, and then you can add points in set for fast animation. So let's say these are 1000 points, and you can see the 1000 points are taking by the way around 14 seconds. This animation, it was taking around 14 seconds. You can, when you will increase number of points, definitely that is going to increase the simulation time. But if you want to keep the simulation time small, let's say you want to increase these points, these 1000 points 100 times, and then want to keep the time of the animation almost equal to what it was in past, like 14.5, close to 14.5. What you can do is you can call these points in sets, and when you call them in sets, then the time it takes for each set is approximately reduces the time it takes for each point. Okay, so let's say you want to increase it number of points 100 times, then if you call it in the sets of 100, the time would look like close to 14.58. We can do it, and that can be done up till this point. The commands are similar, only thing is that the number of points are increased from 1000 to 100,000 times. Now when you run this loop, there is a little difference. You can see 1 and then 100 and then number of points minus 99. So that means the one loop is going to run for 100 times within this command. So similarly, you want to change this x vector and y vector. So every time it is going to create a vector of 100 x points and 100 y points, and then instead of single point, it is going to add the x vector, which is composed of 100 points, y vector which is composed of 100 points, and then finally it will draw that shape. So let's run this and see how it looks. So ignore this because this is the part of the previous one. Okay, there you go. So you can see the elapsed time is 18.80 seconds, which is a little more than 14, but it is not increased 100 times as the data points are 100 times. So 14 multiplied by 100, so let's say 1458. So it is not increased that much. So you can reduce by calling it in the form of frames. Another thing is what you can do is you can use the limitrate command. And a limitrate command, what it does is it reduces the number of frames per second to 20 frames per second, and then you will see a very fast response. So where you can specify it, you can specify just in front of draw now. So when it is drawing the points, it is taking care of this limit rate. So that means the number of frames per second are reduced to that default limit rate, that is 20 frames per second, and then finally the figure would be plotted very quickly. So let's first plot this figure, dock it, and let's run this section. So you will see this is quite fast. Okay, and by default that's the rate if you use draw now limit rate. Now one is slow, one is fast. Now you want to control the animation speed by your own choice. You can do that, and that can be done by using the frames per second. Okay, so first of all you have to create this animated line. Let me close this. Until here everything is exactly similar. You can see there are 10,000 points. By the way, in past you are looking around 4.4 seconds with the here you can see with the limit rate command, and now you want to get some intermediate rate. So you will use tick command, which is the starting time, and talk command, which is the ending time. Within that, what you are doing is this is for loop, and now you are creating this if condition if b is greater than 1/30. So this 1/30 is basically frames per second. So when the screen time is greater than 1/30 seconds, then you are going to draw it. If it is less than 1/30 seconds, then you are not going to draw it. And within that you are calculating this time by using this b. So b is equal to talk, b is equal to talk here, a talk of a. So that means a is equal to tick start here, and then b is a talk of a. Then that means you are going to check the time, and then if it is greater than 1/30, you are going to draw it. If it is less than 1/30, you are not going to draw it. So that's how it will work. Let's run it. So you can see it's pretty quick based upon what you need. And let's say you want to further reduce the speed, you can do it. Let's say this is 1/30 and you want to update it, let's say every 1/90 seconds. Let me run it. Yeah, I think I have to clear it, and I can run this one. So you can see. Okay, now let's change it dramatically. Let's say 1900. Okay, so you can see it is now very slow. So the greater the denominator, the slower the speed is, and if you want to increase the speed, you can do it by changing this time. So I hope this video will help you out. In case if you have any questions, please write them down in the comments below, and I will try to answer them in the comments. In case if there is some explanation required, I will create a video for that. If you like my video, please like the video and subscribe to my channel, and we'll see you in the next video. Till then, bye bye.